Now, what conditions will arise in the circuit? There are various ways, no? Definitely VA greater than Vx. So therefore positive, when I close switch, positive charge will flow. First, what will happen here? The positive charge will leave the positive terminal of cell, and negative charge, no? First, it will make the charge in capacitor 0. Again, VA will be greater than Vx, charge will flow, and finally what happens? The charge across capacitor will be minus Q. And finally, VAB equal to Vxy equal to E. And what is the charge? C into Vxy equal to C into E. This will be the final charge. And here I'll put a condition, let Q equal to C. If you want to choose some values, no problem. See the capacitance. Tell me, like, look at the plate X. What was the charge of plate X? Minus Q, and it has become plus Q. So definitely some charge left from positive terminal of the cell. See, in every problem, you are supposed to trace out a charge. This was from the beginning I'm showing it here. No? What is work done by cell? Positive or negative? Positive charge left positive terminal. So work done by cell will be positive here. So again, what is the how to calculate the charge? I'll take help of the plate X at plate X for plate X. So what was the earlier charge? Minus Q. Some Q charge entered and it has become plus Q. So how much it is? 2Q. So how much of charge the cell in fact has pushed, that one 2Q charge it has pushed here. Means minus 10 liters are there to become plus 10 liters. So how much of water the tap should supply? First, the 10 liters you should supply, so that minus 10 liter plus 10, it will become 0. Then it will add another 10 liters. It will become plus 10. Sir, negative water, analogy, logical thinking. Finally, what should be the like amount of water should be plus 10 liter. Initially, how much is there? Minus 10 liter. So what tap will do? First, it will add 10 liter, so that will become 0. Then it will add another 10 liters. Total, how much of water has come out from the tap? 20 liters. This is the idea. This one. So again, the what about heat generated? It will be UI plus work done by cell. There's a one best formula what I'm introducing here. Whenever you get anything of the heat generated or work done, heat generated, no, this is a thing. Work done by cell. If a cell does positive work, substitute positive work. If a cell does negative work, substitute that with sign. Initial energy in circuit, Q square by 2C. Work done by cell, 2Q, Q into E, no? Total charge, how much left over? Q into E. Finally, Q square by 2. But sir, negative. So if you're getting confusion with sign, you do right. Plus E generated. What is small q equal to? 2Q. So Q square by 2C, 2Q E. So what is the heat generated will be 2Q into E. Q is equal to C into E. So it has to do this much of work. This much of, sorry, heat will be generated. So what is the basic idea? If a positive charge leaves positive terminal, if a positive charge leaves positive terminal or positive charge enters positive terminal, either of thing. Now, what you have to conclude here then? This is the EMF of cell E. Work done by cell is positive. Then how much it is equal to? charge into E. If similarly, if a positive charge red color, then work done by cell is negative. Then how much work done by cell is should be minus of Q into E. So nothing but what do you mean by its cell supplies energy? What is the meaning of this? Cell supplies energy to capacitor or to other cell. We are not bothered. Altogether, it supplies energy to circuit. What do you mean by this negative? Absorbs. Don't say absorbs. Consumes or stores energy. Cell stores energy, or in another sense, accepts energy. If you go for current density, what you call this as charging, this is discharging. So if you want to bring that word, you can use word. This is discharging. This is charging. Because to write that, because we should be very clear about work done by the cell. So here nothing but it is getting energy from the circuit. Here it is in the first case supplying energy to the circuit. So whenever, if you get this one, no, so we are going to use this basic thing here. Okay, so this is about the basic introduction of the capacitor. So tomorrow I'll continue from here.